For lesson 8's homework, we're going to work on solving our quadratics with inverse operations. So we're going to solve each of the following quadratic equations for all real values of x. And we put the word real in there just as a reminder. If we get any of our negative square roots, we want to be careful with those. And then we want to write our answers in simplest radical form if the solutions are irrational. So if we look at the first one, x squared equals 81, well, that's a simple square root both sides. 81 is a perfect square, nice and easy. You get plus or minus 9. Remember, as we get into this now, you want to make sure you recognize when you're solving for x and you take the square root, you're going to end up with the positive and the negative, so you end up with that plus or minus on the other side. In the middle, x plus 3 squared in parentheses equals 25. So the parentheses by itself, so we can just square root both sides. When you square root the parenthesis, you get what's left inside. Square root of 25 is plus or minus 5. We'll subtract the 3 on both sides. And remember, the plus minus makes us write it like this. X equals negative 3, because that's the number we brought over. That goes first. And then the plus or minus 5. Because this branches off into negative 3 plus 5, which means x is 2. And then negative 3 minus 5, which means x could be negative 8. And there are two answers in the middle. If we look at the last one, we will start by subtracting the 5 on both sides. So that gives us negative 2 parentheses x minus 7 squared. Now be careful, there's a lot of negative signs here. Equals negative 200. Divide both sides by negative 2. You get x minus 7 squared equals 100. Parentheses is the only thing left now, so we can take the square root. X minus 7 equals plus or minus 10. We'll add the 7 over to the other side. And this is exactly like the middle. Because there is a plus minus, we can't just add them together. So now it branches off. X equals 7 plus 10. So x could be 17. Or x equals 7 minus 10, which means x could be negative 3. So as we move on now, we'll continue with the same process here. Plus 6, 2x plus 1 squared equals 25. Square root both sides. 2x plus 1 equals plus or minus 5. Subtract the 1 on both sides. Again, we cannot do that yet. And now what we have to do is, normally we have x by itself here, but now we have to divide everything by 2. So we get negative 1 plus or minus 5 divided by 2. Now that looks pretty awful, but we can actually do this no problem. So x equals negative 1 plus 5 over 2. Well, negative 1 plus 5 is 4, and 4 divided by 2 is 2. So then we get x equals negative 1 minus 5 over 2. Negative 1 minus 5 is negative 6. Negative 6 divided by 2 is negative 3. So although it looks like something that is very challenging, it actually just adds one little extra step for us at the end, but again, doesn't change our process. In the middle, we will square root. Now the difference here is that 18 is not a perfect square. So what does 18 split into? We get square root 9, square root 2. So x minus 5 equals, and again, just because it wasn't perfect doesn't mean we can forget about our plus or minus. So x minus 5 equals plus or minus 3 square root 2. We'll add the 5 to both sides. X equals, the 5 has to go first because that's what came over, plus or minus 3 square root of 2. Now, unlike the previous problem and the ones on the top of the page, this is going to be an irrational number because of that square root. So we're actually just going to leave that answer exactly the way it is. In the last one, we'll start by subtracting the 400 on both sides. So negative 16 times x minus 2 squared equals, and I want to make sure I don't do this wrong. So 272 minus 400 is negative 128. We'll divide both sides by negative 16. That gives us a positive 8. So x minus 2 squared equals positive 8. Square root. Just like the last one, 8's not perfect, so we got to split it. Square root 4, square root 2. X minus 2 equals plus or minus 2 square root 2. We'll add the 2 to the other side. Again, the number that you move over goes out in front. And then we get plus or minus our 2 radical 2. Again, those do not combine because there is a radical, and therefore will give us an irrational answer. So now we get some that are kind of like just written a little bit tricky, but there's really nothing different about them. So we'll start here by minus 11. Minus 11 gives us negative 49x squared equals negative 81. We'll divide both sides by a negative 49. So x squared equals, now it'll be interesting to see what this gives us. Negative 81 divided by negative 49 gives us that pretty terrible decimal. So if we go math, enter, okay. So really what we get is we just get those two numbers in a positive form. The two negatives are going to cancel out. So we square root both sides. Now, when we square root a fraction like that, it really means that we have the square root of the top over the square root of the bottom. So x is going to be equal to, now we're still going to be plus minus. Now both of those happen to be perfect squares. The square root of 81 is 9. The square root of 49 is 7. So x equals plus or minus 9 square root 7. So again, a little bit of a different answer, but still falls into the same process, same pattern. In the middle, we will be plus 24, plus 24. We get x plus 3 squared equals 24. Square root. 24 is not perfect. Splits into square root 4, square root 6. X plus 3 squared equals, almost forgot my plus or minus 2 radical 6. And actually I wrote my parenthesis wrong because I took the square root, so I should just have x plus 3. I'll subtract my 3 on both sides, and I get x equals negative 3 plus or minus 2 radical 6. And again, I can't go any further with that because we don't have the ability to work with the square root. So we're going to subtract 12. 3x plus 1 squared equals negative 12. We'll divide both sides by 3. X plus 1 squared equals negative 4. Square root both sides. And I know it looks appealing, but remember what your calculator says. If you take the square root of a negative number, it tells you error, non-real answers. So even though 4 is a perfect square, negative 4 is not. So therefore, there are no real solutions to this problem. And like I said, that means we can't solve for those types of problems as of now. And that's going to be our homework for inverse operations.